Hey folks, today we're going to work on worksheet number 7. It is a long one. So just so that you're aware, I wanted to make you know that it's going to be long. So again, if you need a particular problem, kind of fast forward to where you need to be and you can work from there. Okay? Alright, first thing we have to do is identify what type of reaction this is. You should be able to tell that this is a double replacement reaction because we have two compounds. So that means the metals are going to replace each other, maybe. So we should be creating silver chloride, and we should be creating sodium nitrate. Okay, and we have to look at our solubility table to figure out what is aqueous and what is solid. Now we've already figured out that salt and silver nitrate are aqueous. You're given that, and you should know that anything with nitrate is aqueous. So the question is silver chloride a solid or is it not? So if we look down, we look for silver and we look for chlorine. Here is silver and here is chloride. Silver chloride is right there, and it is a solid. So silver chloride is our solid, so that goes there. Silver's +1, chlorine's -1, sodium's +1, nitrate's -1. Everything is +1, -1. Everything balances. So we have a balanced chemical reaction. And we put the state of matter for everything. So we're done with that one. And this, by the way, we did say it, but I'll put it on here anyway. This is a double replacement reaction. Alright, how about our next one? Well, our next one, clearly we have an element in the compound, so that is a single replacement reaction. Now, it's only going to work if iron is higher on the activity series than copper. So I look for iron and I look for copper. There's copper down there, and iron's way up here. And iron's a +3 and copper's a +2. So this is going to become iron sulfate and copper. And we said that iron is +3 and sulfate is -2, so that becomes a 3 and a 2. Over here, that's copper. So to make this work, I have to have 3 of these, I have to have 2 of those, and I have to have coppers. I have to have 3 coppers. So I now have a balanced chemical reaction. Copper obviously is a solid. We all know that copper is going to be a solid, and iron sulfate is going to be aqueous. Alright, so that's number 2. Number 3, you should be able to look at this and you say, well, this is a carbon-hydrogen compound, and I'm combining with oxygen. That means it's a combustion reaction. Combustion reaction, in other words, fire. And we've always produced carbon dioxide and we produce water. And so what we have to do is then balance our equation. So we have to have 4 of those. We have to have 10 of the 5 of these. Oops, but we can't have 5 because that's going to make a negative number, so we're going to multiply everything by 2. That's going to be a 10. That's going to be an 8. If we have 10, that means we have to have the thing that goes in here. That's a 2. So that we have 8 of those. So we have 20 hydrogens, and that's correct. And we need to have 16 plus 10 is 26 oxygens, so that's 13 O2s. So carbon dioxide is a gas, and water is going to be a gas because it's hot, so it's steam. So those are our that's our final formula. All right, number 4. We obviously have a double replacement reaction, and let's see. We're told that both of these are aqueous. So our metals would replace each other, so we would be left with barium sulfate and sodium nitrate. Now we're not balanced yet, but we have to figure out if this even bothers. We know that anything with nitrate is going to be aqueous, so we have to look at barium sulfate and figure out if barium, which is here, and sulfate, which is here, we have to figure out if it's a solid or it's liquid or gas or aqueous or whatever, and it's solid. So our barium sulfate is going to be solid. So that tells us this reaction will actually happen. Let's look at our charges. Barium is +2, sulfate is -2, so they cancel. Sodium is +1, nitrate's -1, so they cancel. So now we have to balance the equation because our charges are balanced. We notice we have one barium, but we have two nitrates, so that means we have to put a 2 over here. We have two sodiums and we have one sulfate, so we are balanced. So we have our final reaction, and it is double replacement. Alright, how about this one? Well, this one is going to be single replacement because we have a compound and an element. And if you happen to remember, lithium is the highest thing on the activity series, so lithium will replace anything. And lithium has a +1 charge because it's in group 1A. It's an alkali metal. And that is going to go with nitrate, which is a -1. And we have silver, which is all by itself, which is going to be a solid. Lithium nitrate is going to be aqueous. And everything is balanced. And just to be sure, we said lithium is going to replace silver. Lithium is all the way at the top of our activity series, way up here, and silver is way down near the bottom. Okay. So that's our final equation, and that's single replacement. Alright, how about our next one, number 6? Lithium, bromide, and copper. Well, we just said lithium is the top dog on the activity series. Lithium's already with bromine, copper's not going to replace it. Nothing happens here. How about this one? Magnesium sulfide. Notice it is a solid. That tells me right now, and I know sodium hydroxide is aqueous, by the way. Magnesium sulfide is a solid. All right, so there's no reaction here, right? Because they both have to be aqueous for this to happen. So that's not going to happen. Remember, the two things on your left have to be aqueous. The two things on the right, one of them needs to be a solid or a liquid or a gas, something other than aqueous. All right, number 8. We look at number 8. Again, this is the same thing we had with lithium a moment ago. We noticed that lithium is the highest thing on our activity series. So as a result, this cannot happen. There is no reaction here. It would be single replacement, but there's no reaction. But this one, on the other hand, will happen. Right? This one will happen because lithium is going to replace the mercury. So we're going to end up with mercury plus lithium chloride, and that's +1 -1. So they cancel each other out for charges. Now when I balance the equation, I have to have 2 lithium chlorides because of the 2 over here, which means I have to have 2 lithiums to make that happen. And my mercury, if you remember, look at your periodic table in class. If you remember, mercury is blue. It is a liquid. So mercury is a liquid. It's the only liquid metal that's out there. And lithium chloride will be aqueous because it's still in solution. Okay, that's number 9. How about number 10? Number 10, you should immediately recognize that this is a combustion reaction. We have a carbon-hydrogen or carbon-hydrogen-oxygen compound mixing with oxygen. It always produces carbon dioxide and water. And we are going to have 3 carbons, and we're going to have 8 hydrogens, so that's 4 times 2 is 8. So that means I've got 2 plus 3, which is a total of 5 O2s. So that's a combustion reaction. Ooh, now we're getting into names. So this is going to add a little bit of confusion here. All right, we have ammonium nitrate and we have sodium chloride. So let's see if anything happens here. We have ammonium nitrate and sodium chloride. Well, let's see, ammonium nitrate. Remember that anything with nitrate is going to be aqueous, and we have sodium chloride. Sodium chloride. There we are, which is aqueous, which we already knew. And we're going to come over to sodium nitrate, and clearly that has to be aqueous. And then we come up here, and we come to ammonium chloride, and it's aqueous. So all 4 things are aqueous. So before I do anything here, I can just figure out that no reaction happens because it's a double replacement reaction, because they're both compounds. Everything's aqueous, so we can just skip 11 and say it does not happen. All right. Looking at number 12, we have potassium chloride and we have zinc phosphate. So let's look at those. Again, this is double replacement because they're both compounds. So potassium chloride, everything with potassium is aqueous. So we already know that, so that one's easy. And zinc phosphate. Zinc is all the way down the bottom. Now we come over here to zinc phosphate, which is 3 from the end. And, ooh, wait a minute, that's a solid. So we're taking zinc phosphate, which is a solid, and putting it with potassium chloride. So no reaction happens here, all right? Because zinc phosphate is a solid. Remember, your two reactants must both be aqueous. So that does not work. How about zinc being added to lithium chloride? Again, remember that lithium is the most active thing. When we have our activity series, lithium is the most active thing. Lithium will replace anything, but since lithium is already with chloride, no reaction happens here either. So that's simple. How about number 14? Iron is added to a solution of silver nitrate. Well, let's see. Where's iron? Iron is added to silver nitrate. So the iron will replace the silver. The iron is going to be a +3. So we actually have to do this one. So Fe plus silver nitrate, AgNO3, gives me iron nitrate plus silver. All right. Now let's see. Silver, nitrate, +1, -1, they cancel. Iron is going to be +3 with nitrate of -1, so I need 3 of those. And so that means I have to balance my reaction, so I need 3 here, and I need 3 here, and everything is now balanced. And iron's a solid. Silver nitrate is going to be aqueous. Your iron nitrate is going to be aqueous, and your silver is going to be a solid. Okay, single replacement reaction, very, very common. Okay, let's keep going. When we look at number 15, we have an iron nail. And the iron nail is being added to a solution of copper sulfate. Actually, copper sulfate is being added to the iron nail, probably, poured on top of it. But does this actually happen? Well, we have iron, which is Fe, and we have copper, which is Cu. Well, here's copper down here, and iron Fe. Where is iron? There it is. Okay, so iron is above copper, so iron will replace it. So let's go and write this one. Fe plus copper 2 sulfate, and iron's going to be +3. So it's going to be iron sulfate plus copper, and so we have to have iron 3 sulfate. Sulfate has a 2 charge, so that means I need 3 of these, 3 of these, and 2 of those. So I'm now balanced. Solid, aqueous, aqueous, solid, and single replacement reaction. Okay, 16. Octane is burned. It even tells you that it's a combustion reaction right there, that it's burned. The fact that it's air, we're looking at the oxygen out of this, so it's C8H18 plus O2 gives you carbon dioxide and water. All right. So I'm going to start with the hydrogens because I know that's going to mess me up, because 18 hydrogens is going to give me, it's going to give me 18 of these. Sorry, it's going to give me 9 of these, right? When it gives me 9 of those, I have 9 oxygens, and I have no way of doing this. So I multiply everything by 2. So I'm now going to have a total of 16 carbons. I'm going to have a total of 18 H2Os, which is 9 O2s, plus 16 O2s gives me 25 O2s. So I now have a balanced chemical reaction. The first one, octane, is in gasoline, so that's a liquid. Or, I don't know, yeah, because it's not dissolved in water, so it's a liquid. And oxygen's a gas, and carbon dioxide's a gas, and water's going to be a gas because it's hot. Alright, that's number 16. How about number 17? Let's see, we have tin sulfate and ammonium hydroxide. So tin, it's tin 4 sulfate and ammonium hydroxide. Tin 4 sulfate and ammonium hydroxide. There's hydroxide and there's sulfate. So we have ammonium hydroxide's aqueous and ammonium sulfate's aqueous. And, ooh, there's tin. There's a solid down there. We have an aqueous over there. So the tin 4 hydroxide is going to be a solid. So tin 4 hydroxide, that's what we're producing, so that's going to work. We'll be okay. So we have tin 4 sulfate plus ammonium hydroxide. Ammonium is NH4. OH is going to give me ammonium sulfate plus tin hydroxide. Tin 4 hydroxide. Right, and this one's going to be a solid, and the rest are going to be aqueous, aqueous, aqueous. So the tin hydroxide is what's pushing this equation. It's tin 4, so tin 4 sulfate, that's a plus 4 and a minus 2, which reduces to a 2 to 1 ratio. So I have to have 2 sulfates. Ammonium and hydroxide are 1 to 1. Ammonium and sulfate are plus 1 minus 2, so I need 2 ammoniums. And SnOH, I have to have a 4 after that because it's tin hydroxide. Now I have to balance, and I notice with the tin I've got 1 of each. The sulfate, I've got 2 on the left, I have to have 2 on the right, which gives me 4 NH4s, so I put a 4 in front of there, and that gives me 4 H's, OH's, so I am now balanced. Right? And I have a double replacement reaction that actually works. Alright, let's look at number 18. Sodium hydroxide and hydrochloric acid. Sodium hydroxide, and hydrochloric acid is HCl, hydrogen chloride. And I believe that's chloride there. And hydrogen chloride or hydrochloric acid is aqueous, and anything with sodium is aqueous. And we're looking at hydroxide, which is right here. Now we notice that we have water. Ooh, cool. So that's something other than aqueous, so that's going to be our driving force is the hydrogen. Hydroxide, also known as water. So we have NaOH plus HCl gives me, well, we have HOH, which is water, and that's a liquid, plus sodium chloride, which is aqueous. And everything is plus 1 minus 1, so everything cancels. Right? So we're good. Okay, 19, calcium hydroxide and sulfuric acid. So let's look at what we have here. Calcium hydroxide, calcium, which is here, and hydroxide, which is here, and we have, oh, we're already stuck. Calcium hydroxide is a solid. No, that's not going to work. We need to make sure that calcium hydroxide is aqueous. So there's no reaction here in this double replacement reaction. All right, how about number 20? Nickel is added to hydrochloric acid. Well, that's nickel and hydrochloric acid, and that should produce, nickel chloride plus hydrogen gas. Right. Well, is nickel higher on the activity series than hydrogen? Well, let's see. Where is nickel? There's nickel, and there's hydrogen. So nickel is higher than hydrogen, so this reaction will actually happen. Nickel is going to displace hydrogen. Hydrogen is going to come off as a gas. Nickel chloride will be aqueous, as will hydrochloric acid be aqueous. Nickel will be a solid. We think of it, nickel's a metal, so that's a solid. But because we have an H2 on the right, we have to have 2 there. We have to have 2 nickels because we have to have 2 nickel chlorides. And we're done. Okay, let's go on to number 21. Number 21 says cadmium is added to water. So let's see, that means cadmium plus HOH, it's easier to write it that way, is going to give me, well, the cadmium and the hydrogen have to replace each other, so it's CdOH plus H2. Well, let's see what happens. Does cadmium actually replace hydrogen? Well, here's cadmium right there, and here's hydrogen all the way down the bottom, so cadmium will replace hydrogen, so this reaction actually does happen. Cadmium is a 2+ charge. Animals, this has a 2+. OH has a 1-, so I have to have 2 of them. And I have to have 2 H's and 2 OH's on the left to balance what I have on the right. So that is my single replacement. And cadmium's a solid, water's a liquid, cadmium hydroxide is aqueous, and H2 is a gas. How about 22? Hydrochloric acid is added to copper metal. So let's see, that means that we have HCl plus Cu. Now, is copper higher than hydrogen on the activity series? Well, wait, they're right next to each other. Hydrogen is higher. So that means that the chlorine would rather be with the hydrogen. It's already with the hydrogen, so no reaction happens for number 22. All right, only a couple more. Here's number 23. We have solid cobalt is added to a solution of barium hydroxide. So let's look at cobalt and barium on our list. And here we have, I can see cobalt. And where in the world is barium? Barium's up near the top. Barium will replace cobalt. Oh, well, it already has. Barium's already with hydroxide, so no reaction happens here. Don't even need to write that one. All right, how about 24? 24, you should immediately recognize that this is a carbon-hydrogen-oxygen compound being burned. Plus oxygen gives you, all right, so this is CO2 and water. It always gives you carbon dioxide and water. And we have, okay, let's see, what do we have? We have 1 carbon, we have 4 hydrogens, so we're going to have to put 2 there. All right, this is going to get messy, so that doesn't work well. So let's double this thing. So we now have 2 carbons, we now have, let's see, we've got 8 hydrogens. That means we have 4 of those. That means we have 2 O2s. We have 2 O2s there. Did I do that right? We have 4. We have 4 O2s. Is that right? Did I do that right? 4 O2s. We have 2 O2s there. We have 2. Oh, we shouldn't have done that. So we shouldn't have doubled anything. So that should be a 1. And that should be a 2. And that should be a 1. And that should be a 2. Let's make sure this works. We have 1 carbon. We have 1 carbon. We have 4 hydrogens. 2 there, 2 there. That's a total of 4 hydrogens. That's good. And we have 1. That's 5 oxygens. We have 2. We have 4. That does not work. All right, so we're still not right. Let's try balancing again. I've made a mistake. Plus O2. Let's try doubling it. Let's do it the way we wanted to originally and see if we can manage to make this work. CO2 plus H2O. We now have 8. We have 4. We have 8 hydrogens. We have 4 waters. We have 2 carbons. So we have a total of 4 oxygens here and 4 oxygens there for a total of 8 oxygens. I did it again. So what am I doing wrong? I still don't see what I'm doing wrong. 1 carbon, 4 hydrogens, 1 oxygen, 5 oxygens on this side. That does not work, and I can't have 5 oxygens. Alright, but if I double it, I have 2 of those. I've got 2 O2s. I've got 2 O2s. I've got a total of 8. So that, oh, wait. There's where I'm going wrong. Okay, here we go. We've got 2 O2s. We've got 4 oxygens here, and we have 4 oxygens there for a total of 8. But here we already have 2, so that means I have to have 3 there because I have to have 6 oxygens here plus 2 oxygens there, give me a total of 8. There's my problem. Okay, so I'm finally balanced. Sorry guys, that took a while. I was clearly doing something wrong. Methanol. Methanol is a liquid at room temperature, and oxygen's a gas, and carbon dioxide's a gas, and water's a gas. Sorry that took so long, folks. All right. Number 25, solid gold is added to hydrochloric acid. So what happens? Well, gold is the last thing down on the activity series, and hydrogen's above it. And chlorine is already with hydrogen. So no reaction happens on number 25. That's a nice way to end this because that was our last problem. So I hope it helps. If you have questions, please come see us in class. We'll be happy to help you. Have a great day. See you later.